Let's solve some quadratics. So let's say we're given y equals -2, x minus 3, x plus 4. So this is a quadratic in factored form. So how can we solve this thing? Well, it's actually pretty straightforward. See, the solutions to this, or the x-intercepts, or the roots, or the zeros, whatever we wish to call them, those are the values for x which make this whole thing equal 0, right? Because when y is equal to 0, the x value that accomplishes that is your x-intercept, right? You set y to 0, solve for x. And so you can see that if this whole bracket here was 0, 2 times 0 times whatever that is, it would all become 0. Or you could have this bracket equal 0. If this bracket's equal to 0, 0 times whatever this is times -2, it's all going to become 0 as well. So all you have to do is set each of those brackets to 0 and solve for x. So like x minus 3 is equal to 0, x plus 4 equals 0. Solve for x in each case. X equals 3, x equals -4. Those are your two solutions, right? Because if I plugged in 3 for x, this would all become 0. If I plug in -4 for x, this thing would all become 0, right? And your y value would become 0, which means it's an x-intercept. If you want to graph this, you can do that as well, right? Your roots are 3 and -4. Just like that. And there's a negative on the front, meaning it opens down. So your graph would look something like this. And yeah, you could do a little bit of work to figure out what your vertex is, right? What your y-intercept is. But again, just as a sketch, that's probably all right for our purposes. Let's do another one. Might look a little bit different. But what if you have y equals 2x plus 1 times x minus 3, and I say solve this quadratic, right? That means what are the solutions? It means what are the x-intercepts, right? What are your roots? What are your zeros? You do the same thing, right? You set each bracket to 0, and you solve for x. So 2x equals -1, divide both sides by 2, x equals -1/2. Over here, you would just get x equals 3. So those are your solutions, x equals -1/2 and x equals 3. So if you were graphing this one, so you have an idea of what we're looking at, you have the x value 3, you have the x value of -1/2. Those are your roots. There's a positive 1 on the front, so it's opening up just like this. So that would be your graph. Okay, that's if you have factored form. So factored form is pretty straightforward, right? You can get your roots directly from those brackets, right? Now, what if we have vertex form? What if I have y equals 9 times x minus 1 squared minus 4? How would I find the roots for this one? Okay, well, let's just set y to 0 and solve for x, right? So y is 0, 0 equals 9, x minus 1 squared minus 4. Bring the 4 to the other side. 4 equals 9, x minus 1 squared. Divide both sides by 9. 4 over 9 equals x minus 1 squared. Square root both sides. Square root that, it'll cancel with the 2. Square root this. And you get plus and minus when you take the square root, right? And what's nice is square root of 4 is 2, and the square root of 9 is 3. So you can actually write it like plus and minus 2 over 3 is equal to x minus 1. And from there, move the 1 to the other side. You get 1 plus or minus 2/3 is equal to x. So we get two answers for x, right? You get x is equal to 1 plus 2/3, which 1 is really 3 over 3. So 3/3 plus 2/3, which is 5/3. And you get x is equal to 1, which is 3 over 3, minus 2/3, which would equal 1/3. So these are the two answers that you get for x. Right? Those are your two solutions. And so if you were to graph this, the graph would look something like this, where this is a third, this is 5/3, just as a very rough sketch, right? Okay, let's look at another one. What if I have standard form, right? I could have y equals 2x squared plus 5x plus 3. What would I do here? Well, if you have standard form and you need to find the solutions, the best way to do it, I would say, is try to factor it, right? Try to get it into factored form and then find the roots, right? The way that we were doing it initially. So how would I factor this? Well, I have to use decomposition, right? It's not a simple trinomial. There's a number out here in front of my x squared. So I have to use decomposition. So we have to remember how we do that, right? We do the first number and the last number multiplied together. So 2 times 3. 2 times 3 is 6. So I'm looking for two numbers that multiply to 6 and add to 5. And those numbers, I think, just so happen to be 2 and 3, right? Coincidentally, the same as those. It usually doesn't happen, but that's okay. So 2 and 3. So what that means is we can decompose that middle term. So we have 2x squared plus 2x plus 3x plus 3. And it doesn't matter if you put the 2x here, or the 3x here or here. Like, these could be swapped. You get the same answer at the end of the day. All right, so we decompose that 5x into 2x plus 3x. Now we factor by grouping. So we group the first two. I can factor out a 2x. I'll be left with x plus 1. Factor the second two. Take out a 3. Be left with x plus 1. I now have two terms, and I can factor out an x plus 1 from each term. So x plus 1, and I'm going to be left with the 2x plus the 3. This is now factored form. So what I'm going to do is set the thing to 0 and then solve for each bracket, right? Or in other words, I can just set each bracket to 0 and solve for x. So x plus 1 is equal to 0, and 2x plus 3 is equal to 0, right? Because either one of these being 0 will make the whole thing equal 0, right? So solve for x equals negative 1, or x equals, bring the 3 to the other side, negative 3, divide by 2, negative 3 over 2. So these will be your two solutions for this equation. Let's do another one. Okay, let's say you have y equals 3x squared plus 7x plus 3. So another standard form, and it looks like we'll have to use decomposition. But something interesting happens with this one. When you do 3 times 3, you get 9. And so you'll be looking for two numbers that multiply to 9 but add to 7. And the problem is, there are no two numbers that multiply to 9 and add to 7, right? The only numbers that multiply to 9 would be 3 times 3 or 9 times 1, and neither of those combinations will add to 7. So you can't factor this. So if you can't factor it, how do you find the roots? How do you find the solutions? This is where we use the quadratic formula. And this is one way to do it. There's also another way, which I'll cover in a minute. But the quadratic formula goes like this. You say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Lots of people have this memorized. If you'd like to, you can absolutely do that. A little secret I'll give you now. This equation is actually derived from completing the square, except you use variables and then you rearrange for x and then you get this thing. So we'll use this equation for now, but when I solve it the other way, what I'm going to do is essentially complete the square. And actually, I'll show you that derivation later. I'll show you how we get this equation by completing the square. And in the future, you can even solve these questions simply by completing the square instead of using the formula. Okay, for now, let's do this. So x is equal to, first we have to say what a, b, and c are, right? Well, a is your first coefficient, b is the second coefficient, and c is that last number, the constant. So negative b, that means I put negative 7, plus or minus square root of b squared, so 7 squared, minus 4 times a, which is 3, times c, which is also 3, divided by 2a, so 2 times 3. We calculate this. We get x is equal to negative 7 plus or minus the square root of 7 squared is 49, minus 4 times 3 times 3 is 36, so 49 minus 36 is 13 all over 6. Okay, so take your time when you're doing that, right? You don't want to make a mistake. So you get two answers here, right, because of the plus or minus. You get negative 7 plus root 13 over 6, and you also get negative 7 minus root 13 over 6. And if you want, you can figure out what these are as decimals approximately, right, to help you figure out where these intercepts are, right, on your graph. So if you calculate this one on your calculator, you'll get negative 0.566 approximately. This one over here, you'll get negative 1.768. So if you needed to approximate what these values are, you can go ahead and just do it on your calculator. Now, like I said, I promised that I was going to show you where this equation comes from. So let's say you just have standard form y equals ax squared plus bx plus c. And I want to complete the square. How do we complete the square? Well, remember, you want the x squared by itself, so you have to factor out a. If you factor out an a, you're left with x squared plus b over a times x plus c. because remember, you just factor from the first two terms. If you factor an a out of b, you're left with b over a. Because if you multiply this back in, you want to get back to here, right? A times x squared is ax squared. A times b over ax, the a's would cancel and you're left with b. So that's how you have to do that, okay? Now, the next thing we do is we add and subtract that special number, right? What is that number? It's this number divided by 2 squared. So we're going to add b over 2a squared minus b over 2a squared, and then plus c. Okay? Next, I'm going to move this one to the outside. So I get a x squared plus b over ax plus, and if you want to simplify this, you could make it b squared over 4a squared, right? You just bring in that exponent 2, you square everything. Now this one on the outside, you can do the same thing, right? So you have plus c minus, you have b squared over 4a squared. But remember, when you bring it out, that a on the front is still attached, right? Because it was multiplied when it was on the inside. So you have to have an a there. And if there's an a on the outside, that a on the top will cancel with one of the a's on the bottom. So you're just left with minus b squared over 4a. Okay? Next, you can factor the inside, right? This is a perfect square trinomial now. So you'll be left with x plus, remember, it's half of this number. That's the number we add. So it'll be plus b over 2a squared plus c minus b squared over 4a. All right, at this point, what you do is you solve for x. So to solve for x, I'm going to bring these two terms to the left-hand side. So b squared over 4a minus c is equal to a x plus b over 2a squared. Next, I'm going to divide both sides by a to get rid of this a. So you'll have b squared over 4a squared minus c over a. And that's equal to x plus b over 2a squared. Next, you can square root both sides to get rid of that square. And you'll have the square root of b squared over 4a squared minus c over a. And that's plus or minus, of course. And that's equal to x plus b over 2a. Next, I'm going to just switch some things around here just quickly. So x equals, so this is going to be the same. I'm going to have plus or minus my square root of b squared over 4a squared minus c over a. And this b over 2a would go to the other side. So in this case, it would come here. So I would get minus b over 2a, just like that. And the next thing I want to do is I want to combine these two terms under the square root. And I need a common denominator to do that. So I'm going to multiply the second term here by 4a on the bottom, so that both of the bottoms are 4a squared. But what you do to the bottom, you also have to do to the top, just like that. So I get x equals negative b over 2a plus or minus square root. And these two terms can come together now because they have the same denominator, right? They both have 4a squared as their denominators. So I'll have b squared minus 4ac, multiply those together, all over 4a squared. This next part is fun. So I have minus b over 2a, plus or minus. Square at the top, you just kind of leave it as it is, b squared minus 4ac. But you can square with the bottom separately. Square root of 4 is 2, square root of a squared is a. Both of these terms now have the same denominator. You can put them together and you get negative b plus or minus square root b squared minus 4ac all over 2a. This is your quadratic formula. So all it is, the quadratic formula, and it's doing the work for you, is it completes the square of your standard form equation and then isolates for x. That's all it's doing. And it does the work for you. You plug your numbers in and it gives you the answer. So some people like to solve for x in a standard form equation by completing the square. Some people like to do that. It's fine. Others like to use the quadratic equation. So it's completely up to you how you want to do that problem. But the quadratic equation is definitely quicker in most cases, I would say. But again, up to you.